My goal in this video is to show you the relationship between calculus and pottery. Now, it may not be an obvious one, but it's actually quite simple. Our first step is to pick a function, and my function is 0.8 sine square root plus x. So it's 0.8 times the sine of x times the square root of x plus x. Now, that looks like a really complicated function, so I graphed it for you, and it's represented here on this red line. You can pick any point. I picked from 6.5 to 14.5, and that's going to be eventually what my pot is going to be. So if I take the integral from 6.5 to 14.5 of my function 0.8 sine of x times root x plus x, that's going to find the area under the curve from 6.5 to 14.5. Now, I forgot to add dx. We're going to multiply this whole function by dx. And the reason why we do that is because, if you recall, when we take the integral, it's taking an infinitely small sliver. The width here is dx, and it's calculating the area of this sliver of the graph. So it's basically the dx times the height, and the height is the function. And so when you add many slivers up, it's going to calculate the entire area under the curve of the graph. So this doesn't really look like pottery yet. It looks kind of like a mountain range, and we're going to fix that. The next step you're going to do is you're going to rotate this line around the x-axis. Now, this is the x-axis, just to be clear. And to kind of visualize this, if this is our x-axis here, and the graph goes like that, and we rotate this around the x-axis, and then it's going to come up with this shape that looks a lot like this. Now, the integral no longer accurately represents the area, because this is now 3 dimensions. So we're going to use the disk method to actually find the area of this shape. Sorry, not the area, but the volume. We're going to find the volume of this shape. So we go to the next slide. I've created a 1/2 scale 3-dimensional model of my function. Now, it may look a little different because it's rotated 90 degrees to sit on this flat surface. So if we rotate it back to what the original function looks like, you can begin to see where my function is. Now, it starts at 6.5, and it looks like that, up to 14.5. Now, if I draw on the x-axis here, you can see that I've rotated this function around the x-axis to create this 3-dimensional model. We're going to use the disk method to find the volume of this shape. And we're going to use the area of a circle, pi r squared, to help us find the volume. So we're going to take the integral from a to b times pi. Now, r is our function. R is 0.8 times sine of x times root x plus x, and then the squared, so it's squared times dx. So if we simplify this, this is going to be pi times the integral from 6.5 to 14.5, those are our limits, of our function, 0.8 times the sine of x times root x plus x squared times dx. We can plug this into our calculator to find the volume because it's a little tricky to do it by hand. So if you plug this into your calculator, you're going to get a total volume of 2,638.5. Now we can't forget our units, so we're going to say units cubed. Just as an added visualization, I plugged our function into a three-dimensional grapher. This is from 0 to 20, but it serves the purpose to kind of get that three-dimensional image into your head. Using what we just learned, we can begin to make our pot out of clay. Our first step was to make a hollow cylinder so that we could begin forming the curves of our model. Our second step is to flatten out the top of our cylinder. So to give you a little representation here, if this dotted line was our hollow cylinder, he simply flattened these two sides to create a shape that looked a lot like this. The third step is to form the bottom section of the pot, and he used his fingers to create that indentation, and he's using the sponge to smooth it out. This pot's finally coming together, and it's starting to look like our function of 0.8 times the sine of x times root x plus x. And all that's left to do is to cut this pot off the base and let it dry. And we're going to come out with a pot that's looking exactly like our function of 0.8 times sine of x times square root of x plus x. And that's how you can use calculus to make beautiful pots.